In this video, we will look at how large language models can go beyond text and help analyze images. And specifically, we have taken stock charts here. For example, here we can see that we have shortlisted one stock, Adani Enterprise, and then we are seeing the chart for Adani Enterprise, and below is the recommendation based on the price action. Now, as an aspiring data scientist, we often think of LLM as tools for text generation or question answering. But modern models are multimodal, meaning they can understand images along with text. In this example, our goal is simple but powerful. Take a stock chart image, ask an AI model to perform technical analysis, and return a structured trading recommendation in JSON format. This kind of workflow is useful for automated market analysis, building AI powered trading dashboards, or augmenting human decision making with explainable AI outputs. So we'll be using few libraries to make this application. We'll be using technical analysis library, and which is short for TA. We'll be using Vibe Finance to load the data from Yahoo Finance, and Pandas as the data frame library. We'll also be using LangChain Google Gen AI. This is an abstraction layer over the large language model. So we'll be integrating Google's Gemini 2.5 Flash model for our AI recommendation. Why Gemini? Because it supports multimodal inputs like images. It's a fast and suitable for real-time analysis, and it works well with structured output instruction. We'll be using other libraries such as JSON for structure responses, OS, and temp file for file handling. So let's deep dive into the code walkthrough. We will be fetching the data using this function yf.download. We'll be passing the symbol and the interval for the data, and the period will be 6 years. We activate the function fetch data and pass the symbol as well as interval, and then put it in the pandas data frame. So now we will be adding few technical indicators from technical analysis library, and we are doing this so that in the image, when we pass it to the LLM, they are able to interpret the different signals, basically analyze those signals, and then pass the recommendation based on the data that they have. Now we will be adding simple moving average for 20 days period. Similarly, we'll be adding MACD and RSI. Now to plot this, all these technical indicators as well as the closing prices, we will use matplotlib, and we will give 3 axes. In the first axis, we are plotting close against simple moving average. In the second axis, we are plotting MACD signal, MACD histogram. And in the third axis, we'll be plotting RSI for 14 days period. We'll also give RSI bands, which are 30 and 70. 30 is for oversold period and 70 is for overbought period. Then we put plot.show, and we get 3 charts like this. This is the image that we can load to our LLM model. So we will be storing this figure. So in Google Colab, we don't have LangChain Google Gen AI, so we will be installing this. And then we are using an API key from Google. Right now I have kept it in my secrets file. So this is the way to extract from google.colab, import user data, and userdata.get. This is the variable that I have created. So you can extract your Google API key if you have stored in the secret variable. So now from LangChain Google Gen AI, we import the library chat Google Generative AI. We activate or initialize our model by passing the model name and the API key. Then we are loading the stock chart image that we had created. We load the image as raw bytes. This is important because multimodal LLM expects binary image data, no file paths. Next, we wrap this bytes in a dictionary format. This tells the model what the data is and how to interpret it. So this is the heart of the system. We are creating a prompt, and main things to consider here is we are assigning a role of a stock trader or a professional trader. We restrict the analysis to only what is visible in the chart. We explicitly ask for 3 things: summary, action, and justification. Most importantly, we enforced a strict JSON output format. This is critical in production system because JSON is a machine readable. It avoids hallucination, and it integrates cleanly with API's dashboard or databases. Then we call the LLM by invoking it with the prompt. Here, the LangChain will interact with Gemini model. The model processes the prompt, the embedded image, and returns a structured response. We then convert the response into JSON. At this point, we have a Python dictionary representing the model reasoning. Then we simply call the function getAnalysis, pass the image part, and then look at the response here. As you can see, the AI has generated the response basis the prompt image we had given. Now, all this information currently is in a string format, and we can see that there is a clear distinction here. First part is summary, second part is action, and the third part is justification. So now we can handle this cleanly using JSON. So sometimes there is an extra text around this dictionary, and this can be cleaned up. To handle that, we will create a helper function. So we will extract only text within the curly bracket. This ensures we extract only the valid JSON portion, which is then passed. So this example was to demonstrate how we can combine multimodal LLMs with careful prompt design to solve real-world problems. And the key takeaways were that the LLMs are no longer for text only. Prompt engineering is just as important as a model choice. Structured outputs makes AI system production ready. With small extension, this same approach can be used for automating technical indicators, risk analysis, and AI-assisted trading dashboards. Thanks for watching and keep experimenting with multimodal AI.